I am Manuel Mayorga. I am a sophomore here at Southwestern Oklahoma State University. I am majoring in engineering physics and mathematics. I have been a part of the rocketry team for 2 semesters now, and I am this year's team captain of the SWOSU Rocket Dawgs. In this video, we will go over each piece of the rocket and explain our methodology and our safety measures we took for each piece.
My name is Ethan Lehman. I'm a junior here at SWOSU. I'm the president of Physics Club, and I am majoring in both engineering, physics, and mathematics. I've been a part of rocketry for 2 years, but this is our competition 54 millimeter minimum diameter booster. It is made of fiberglass and is planned to hold a L1090 motor. The fins are also made out of fiberglass and will be epoxy to the airframe itself. And to ensure the fins stay attached to the booster, we will also put a layer of fiberglass cloth and epoxy to the fins for maximum fin security. The motor that we will put in this booster will have an eye hook onto which we will attach a piece of Kevlar rope to this bolt, securing the motor in place, preventing it from falling out. And also to ensure that the motor will stay secured, we are also going to wrap it in masking tape to maintain a tight, snug fit to the airframe.
Hello. What I have here is our interstage coupler concept for what we are going to be using to connect the 54 millimeter minimum diameter booster to the sustainer with a 38 millimeter motor mount. This is not the exact model or version that we plan to use. I simply have this here to demonstrate what we are trying to replicate or modify so that we can fit everything that we need inside of it and it all works. So on this end, we have a tube that will perfectly fit inside the 54 millimeter booster, and we will epoxy that to the halfway point of this section of the body tube that we cut off, so that way it can perfectly fit inside and be epoxied to the halfway point. And on the other end, we will have the smaller tube that will fit directly into the sustainer. And the way we will do this is we will have the smaller tube with centering rings epoxied on one end. We will then put that one end to the halfway point where it meets this end of the other tube. And we will wait for the epoxy to settle. And once we do, we can then slide on this little tapered piece for better airflow and aerodynamics as this passes through the air. And inside of this interstage coupler will be our electronic bay, which I have here. This is a look of what our electronics bay will have, and I will go over a more in-depth explanation here in just a second. However, I do want to point out that for this rocket that we will be using for the Argonia Cup, we plan to be igniting from the booster, which will inevitably make this much longer, so that we can fit this bigger e-bay in size inside. As you can see, they are pretty big in size. So we need to find a way to make this bigger without it having too much body tube. So here we have the electronics bay for the interstage coupler. Since we are going to be igniting the second motor from the booster, more specifically the interstage coupler, we will have 2 easy minis and 2 easy timers from Altus Metrum. The 2 easy timers will sit on one end completely opposite of the easy minis in order to have less wire to ignite the second motor. The Easy Minis on the other side will then have less wire necessary to ignite the separation charges for the parachute. Both Easy Timers will have settings configured to lock out if the degree from the vertical is greater than 20 degrees, and they will also lock out if the speed is less than 200 feet per second as per the requirements of the Argonia Cup rules. This ensures that no matter what, our rocket will only ignite the second motor if the necessary requirements are met.
Hello everyone, my name is Grayson McCullough. I am a sophomore here at Southwestern Oklahoma State University studying engineering physics. And today I'd like to talk to you about our competition sustainer for the Argonia Cup coming up in March. So our plan for the competition sustainer is that we're going to have a 38mm motor tube that we're going to keep epoxied in place using 2 carbon fiber centering rings. Similarly to our booster, we're going to epoxy the fins in the slots in a way that's going to secure both the fins to the body tube and to the motor tube. After that's fully epoxied, we're going to use fiberglass cloth that's epoxied on either edge of the fins like this to fully secure them to the body tube. Also similarly to our booster, we are going to do the same method of motor retention for the J510 reloadable motor that's going to be in this part of the rocket. So we're going to have the bolt further up here, and we're going to attach Kevlar shock rope to the eye bolt of the motor to fully secure it in place. And we're also going to add a layer of masking tape around the motor to firmly secure it to the motor tube. For the upper part of the sustainer, we're going to add a coupler so we can add extra length so we can start retaining the golf balls in the upper part of here. After we add the coupler and the golf balls, we're going to add another through bolt up here that will fully secure the golf balls so they don't vibrate during flight, and also give a spot for the parachute to anchor to the body tube for recovery during the flight.
Hi, my name is Ritu Vishwakarma, and currently I'm a sophomore at Engineering Physics Department in Southwestern Oklahoma State University, and I'm going to describe how our nose cone is going to look like for this year's competition. We have decided to 3D print our nose cone using heat-resistant filaments, but our nose shape is going to be from aluminum, and our nose cone will house electronic bay for their parachute ejection. We're going to use 2 Easy Minis from Altispectrum for the ejection of parachutes and a big red B radio transmitter for the tracking. Just to make sure the electronic bay inside of it stays safe, we're going to use aluminum bulkhead, and our black powder charges will be resting on the aluminum bulkhead.